Well, hello there, guys and girls. Hello, my name's Dr. Weldon. I'm the head of chemistry here at the NIA. I've been asked to do this induction video, which when you get to know me, you'll realize I'm a bit of a technophobe. This is like a horror story for me. So we'll see how we get on. I'm going to ask you to do a couple of tasks. But first of all, let's just give you a basic introduction to why should I study chemistry. We're going to be studying A-level chemistry, OCR-A. And why should you study it? Because it underpins so many other subjects, and it's fundamental to the modern world and modern society. It's essential for meeting our food needs, clothing, shelter, health, energy, clean air, water, and soil. They enrich our quality of life through health and medicine, materials, our energy sources, our power stations. So chemistry permeates your entire existence, really. What else can I say? I originally trained as a biochemist, and I've been a biochemist and a molecular cell biologist most of my life. Spent a long time at university before coming to a secondary school. And chemistry allows you to get to the minutiae of things. Fundamentally, everything's made of atoms, and atoms are three-dimensional arrangements of positive and negative charges without going into even more greater depth. So what are you going to be doing? Well, you're not going to be worrying about that for sure. What you're going to be doing is you are going to be doing a series of modules designed to aid your understanding and increase your depth of understanding of chemistry and how it applies in a variety of different situations. Module 1 is covered over both years. It's the practical component of chemistry. There are a range of assessed practicals that we must cover in order for you to get the skills required for the practical endorsement. So let me just get rid of that little bar. In the first year, you'll do practicals to do with mole determinations, acid-base titrations, enthalpy, so energies of combustion, energies of neutralization, analysis of ions. I think you touch on that in GCSE, and synthesis of an organic liquid, which you won't have done that before. In the second year, we have more practicals to do. Some practicals later on, you will be expected to design them. They're the unscaffolded practicals. And there is a research component to this as well. So you will, by the time you get around to doing that, you'll be well geared up for it. What are we actually going to study? Well, can I get rid of this? There you go. So we will start year 12 looking at physical chemistry. That would be modules 2 and 3, and organic chemistry, which is module 4. And we will get to grips with the atom again and moles. Many GCSE students, I think, find moles pretty tricky. If you're good with moles, then you're not going to struggle too much with this, but you need to know them inside out and backwards. It sounds a little bit harsh, but honestly, if you can't do a mole calculation, A-level chemistry is the wrong place for you. And we will learn a little bit more about electrons and their arrangement and how they're involved in bonding and structure. And you'll find out that everything you were told at GCSE was pretty much a lie. We'll look at the periodic table. We will investigate group 2, the alkali earth metals again, and the halogens, and look at energy, reaction rates. And then we'll take a look at the basic concepts of organic chemistry, go back to hydrocarbons. Many of you will have studied some of this already, but we're going to do it in far, far greater depth than you did at GCSE, obviously. And then if you make it through year 12, okay, we will go into the year 13 work, This is year 13, more physical chemistry and more organic chemistry. And we will worry about that if you get there. Let's hope you're doing. What's your assessment going to look like? This is what it's going to look like. You're going to take 3 papers. The first paper is on the periodic table, elements and physical chemistry. It's worth 37% of your A level. Paper 2, synthesis and analytical techniques. That's worth 37% as well. And unified chemistry, where they can basically ask you pretty much anything they like. 26% of your A level. The practical endorsement, I'll be keeping a track of separately. So every time you do a practical, that is one of the PAGs for the practical endorsement. Then I will make a note of that in a tracker and keep a track of which skills you are accruing. Recommended reading, support materials. Okay, let me just come out of here for a minute. I would say that in terms of recommended reading, what you need to be capable and able to do is all of the things that you found really, really tricky at GCSE. They're the things that I'm going to expect you to be able to do in your sleep. So you may want to invest in a revision guide. This is the OCR A-Level Chemistry Revision Guide. That's on Amazon. We'll get rid of that one. And this is the Pearson OCR A-Level Revision Guide. That's available directly from Pearson. So you may want to prepare in this sense. I would say in terms of reading, make sure that you know your GCSE chemistry inside and out and backwards. And what else would I say? Oh yeah, one really good thing that you can do, and if you haven't done it, it'll be the very first thing that I ask you to do. And that is the first 20 elements on the periodic table. You want to learn them. Learn their names, their symbols. You want to learn their atomic masses and their atomic numbers. And it will be the first tasks that I set you to do for homework when you arrive. But if you've already done it, you're going to find life a lot easier. It's just a time-saving exercise. You will find it will save you a huge amount of time if you are not continuously referring to the periodic table for some of the basic information. And now in terms of tasks, you should have a Word document called Basic September Test. So I'd like you to pause this video and I would like you to take that test and see how long it takes you to do it. Give yourself no longer than 10 minutes. So at the end of 10 minutes, just stop and call it a day just there. Okay, so hopefully you've taken this basic test. I'll just give you the answers so you can find out how you did. What's the charge on? 1, an oxygen ion, it's 2 minus. Chloride, 1 minus. Magnesium, 2 plus. Silver plus. Hydroxide minus. Ammonium plus. Sulfate, 2 minus. Aluminium, 3 plus. Hydrogen plus. A neon ion, not a chance. There is no neon ion. No charge. Question number 2. Can you name these? Number 1, calcium hydroxide. Number 2, silver nitrate. Number 3, magnesium sulfate. Number 4, lithium iodide. Number 5, potassium oxide. Number 6, copper carbonate. Number 7, silicon oxide or silicon dioxide. Number 8, ammonium chloride. Can you write the molecular formula for these things? Aluminium nitrate would be Al, and then in brackets, NO3, outside the brackets, 3. Silver sulfate would be Ag2SO4. Iron 2 carbide would be Fe2C. The common hydride of oxygen, that would be water, so that's H2O. Barium chloride, that would be BaCl2. Ammonium hydroxide, NH4OH. Iron 3 carbonate would be Fe2, and then in brackets, CO3, close brackets, 3. Potassium sulfide, K2S. Did you manage to balance these? Well, if you didn't, don't panic. We will spend lots of time making sure you can do these things. You'll be able to tell if they're balanced because they will simply have the same numbers of atoms on both sides of the forms sign, which of course is the arrow. Right, that's taken up some time. Now, as far as those elements are concerned, take a little look at this. Elements of the periodic table, test 1 to 5. Yep, you'll be tested on them regularly. Let's just take a look and see how you do. You can play along. This is the first test. Which element are those the symbols for? Yep, that would be helium, potassium, sulfur, boron, and aluminium. What's the symbol for these elements? And the answers would be capital H for hydrogen, capital P for phosphorus, capital C, small a for calcium, capital N, small a for sodium, because it was originally called natrium, and O for oxygen. What's the atomic number of these elements? And the answers would be, for lithium it's 3, for nitrogen it's 7, for neon it's 10, for chlorine it's 17, and for magnesium it's 12. And what is the relative atomic mass of these elements? Yep, and the answers would be, for beryllium it's 9, for carbon it's 12, for fluorine it's 19, for silicon it's 32, and for argon it's 18. Okay, that is about it from me. So I will look forward to seeing you all when you arrive in September. Let me go back and find a video that I'm actually, see, that's not it. Told you I'm not very good with technology. And it's over here somewhere. There it is. Wicked. So if I stop sharing the screen with you, then you should be able to see my beautiful face again. Okay. Well, take care over the summer. Get ready to work really hard in September, and we have no idea what that's going to look like just yet, but hopefully I will see you all in the classroom, and I'll see you there very soon. Bye-bye.